It's a good evening over here. I hope everyone is having a good evening at their ends. I am Mr. Ish. Thank you for joining me. Look right here what we have. We have the origin here, x and y axis, and then we have these lines, straight lines, y equals absolute value 2x. Then we have a circle right here. This absolute value function is an even function. But what is our task over here? We have to use trigonometry, algebraic means, to find the area of this shaded region right over here. Everything that is bounded between this absolute value function and then right over here below the circle, that shaded region. Now how can you do it? If you want, you can do everything here in terms of an even function just to one side and then multiply it by 2 because there's symmetry around the y-axis. If you think about a very important circle property, you can draw everything again, and it's something like this we have, and here's our one line. And you know, this right here is my origin, this right here is y equals 2x. I've eliminated the absolute value, so I'm only looking at one side. If you think about this important property, this line right here, both of these lines are touching the circle here at a specific point. That's a point of tangency, or you can say it's a tangential contact over there. And these y equals 2x absolute value functions are considered to be tangent at the circle. You connect that point of tangency to this center, you have here a 90 degrees, and it must be a 90 degrees because it's a property of circles. It's a property that you see in trigonometry and geometry. You have this 90 degree angle here formed. Now take this 90 degree triangle, you have this 90 degree triangle, you pluck it out, this is what I have. Now let me give you a measurement. This circle here has a radius equal to 1, which is this right here. This here is equal to 1, which is that. I have plucked out this, I've rotated and I've made it horizontal. Now I need to start determining some angles. If I can start determining this angle, it will help me out a lot. And I can determine it just from right over here. Tan theta is always equal to your slope. If everything is based off on a reference horizontal, and this here is my reference horizontal, tan theta is equal to your slope. But that slope is coming here from this equation right here, 2x. And you know, when you're looking at y equals 2x, the 2 represents your slope factor. So tan theta is equal to 2, and theta is equal to arc tan or inverse tan of 2. And you can do that right here on your calculator on the DEG mode. Inverse tan, I'm getting 63.435, and that's what I have, 63.435. Well, that's this angle right here. But if I want to determine this angle right here, which you know is this angle, I can minus that from 90 because it's a complementary angle. I'll minus this here from 90, and I've gotten my angle is 26.565. That's what I have, 26.565. And now I can easily determine that the sum of internal angles of a triangle equals to 180. I'll add this to your right angle 90, and I'll minus this from 180. What do I have? 63.435, and that's this angle right here, 63.435. Now, if you focus right here on this representation, and I'm looking at this shaded region over here, then obviously I'll multiply it by 2 because we have even function properties. But I can do area of this triangle over here, this triangle minus area of the sector, which will be generated because we do have a sector over here, will give me area of leftover, which will be this shaded region, which I'll multiply it by 2, and that'll give me my answer. That's what I'm going to do. I have this radius over here of the circle to be 1, and you know that's coming from right here. This radius is equal to 1. It represents the height of your triangle. I can easily determine the base. Tan of this angle right here, 26.565, is equal to opposite over adjacent base, and then b is equal to 1 divided by tan of that angle. And let's do it. 1 divided by 26.565 tan, everything here on the DEG mode, I'm getting here 2. My base is equal to 2. My area of triangle is now easily determined. The base is determined to be 2, half base and height. Area of triangle is 2 times 1 divided by 2, which is 1. Minus now area of the sector. Let's look at this area of the sector, which is, you know, this right here, sector. There's a specific angle over here, and that angle is equal to this angle because you see it's coming out from this triangle right here. This triangle's angle and this triangle rotated here is representing that sector angle theta, 63.435. Area of the sector is equal to a half r square theta. You know r here is equal to 1, so it's meaningless. This right here, radius is equal to 1. You're really looking at a theta, 63.435. You have to convert that into radians, and you can. Do 63.435, multiply that by pi, divided by 180. You've converted a degree into radians. That's my angle. Radius is equal to 1 square, which is just a 1, divided by 2, and that'll give you your area of sector, 0.55357. And I'll put that right here. 0.55357. You minus this from 1. Minus this from 1, that's the area of the triangle, to give you your area left over, which is this shaded region right here. And you're getting here 0.44645. I'll multiply this by 2 because I'm looking at this combined shaded region, and I'm looking at everything in terms of even function, so I'm only doing one side and I multiplied by 2. I'll multiply this by 2 and your answer is 0.89285. The area of the shaded region will be exactly that, 0.89285, and this answer here should be right. Everything coming here from this very important property, a line tangent to a circle when connected to a center of that circle will develop a 90-degree angle, and that 90-degree angle is helping you develop here a 90-degree triangle, a right triangle from which everything then goes off. Have a good day. Thank you. Bye.